Chapter Review 1, problem number 4. For the geometric series 0.5 minus 0.1 plus 0.02, etc., we have a certain sum of n terms being equal to this much. And they want me to find how many terms are in the series, okay? So basically, find n, the number of terms that we are adding from this series, guys, so that all that sum should be equal to 0.416. So let's see. Let me write down the geometric series. Okay, so this is the first term. The second term is minus 0.1. Minus 0.1. Maybe you should understand this series, guys, in the following way. 0.5 plus minus 0.1 plus 0.02 plus etc. Okay, that's a better way to write a series so that you are aware that the second term is negative. This is the first term, this is the second term, the third term, and so on. Okay, fine. So what do I know? I know that if I keep doing this up until the term n, and if I add all of this up until un, I'm gonna get the sum of the first n terms, and they tell me that that should be equal to this number. That's what I know. What else do I know about this series? I know the first term, which is 0.5, and I also know the ratio. Or what I mean is that I can calculate it, right? They already tell me that it's a geometric series. So I know that it should have a ratio. This number times some ratio should give me this. This number times the same ratio should give me this, and so on. So how do I find the ratio if I know this? If I know that 0.5 times r should be equal to minus 0.1, then it's just about isolating r from this equation, and you will know that the ratio is negative 0.2. That is the ratio. Okay, so I know this, and I know this. And we have enough material to answer the question, guys. Let me write the formula for Sn for a geometric series. Remember, we're working with a geometric series, so don't get confused. When you look into your booklet, make sure that to use the formula for the geometric series, which is this. There you go. Let's make the substitution of all this information in here. Then the ratio is minus 0.2 to the n minus 1 over minus 0.2 minus 1. There you go. So this is the equation that I have to solve for n, guys, for n. So I want you to pause the video, and then I want you to arrive to the following. I want you to arrive by algebraical manipulations. I want you to arrive at this 0.0016 equals minus 0.2 n. I want you to arrive at this. Basically, what I'm doing in all of these intermediate steps is isolating minus 0.2 to the n, this term. Get here. Okay, once you're here, let's actually put it the other way around. Minus 0.2 to the n equals 0.0016. There you go. So this is an exponential equation, right? The variable is in the is the exponent. So how do we solve these types of equations? By making use of our knowledge of logarithms. There is no other way to solve this but other than logarithms. If you notice, guys, this has the shape of a to the x equals b. And if you remember, any exponential equation has its counterpart as a logarithmic equation. This is the same as the following. The logarithm base a of b is equal to x. Remember that thing. This is exactly the same as this. And this is what's going to allow you to calculate x, right? X is going to be equal to the logarithm base a of b, okay? The only little caveat, the only little important thing here, guys, is that you should remember, for example, if I consider this, in this equation, then my a is this number, right? And my b is this number. So let me write it down. And my x is the n, which is the number that I'm looking for. Then if I write the corresponding logarithmic equation to this one, to this exponential equation, then I should write logarithm base minus 0.2 of 0.0016 equals n. And supposedly that's it. That's it. I'm gonna write that in quotation mark, right? Because then you can just put this in the calculator. I have the TI in here. I'm gonna do this in a moment. But I tell you that there's a little problem with this. There's a little caveat. You should remember, or you should look up. Go Wikipedia, in the book, it doesn't matter. That the base, when you use the logarithmic function, guys, this base in here, this base is forbidden to be negative. Forbidden to be negative. Okay, we cannot have this negative for some very specific reasons, right? So how can we fix that? How can I turn this thing around? Okay, what we can do is this, guys. Let me erase this thing. So I can fix that problem in this way. I can write this number to the n as this, minus 1 times 0.2, all of this to the n, that's equal to this, okay? And then this is going to be equal to minus 1 to the n times 0.2 to the n, right? Just loss of exponents equals 0.0016. And then notice, guys, that in here, minus 1 to the n will be either 1. All of this is going to be either 1 plus 1 or minus 1, depending on whether n is odd or even. Do you understand that? If n is even, all of these will be plus 1. If n is odd, all of these will be minus 1. Make sure to understand that very well. Pause the video and understand that. Okay, so basically, I already know that this thing has to be positive. In other words, I already know that n should be even. Why do I say this? Why do I say that I know already that all of this number, minus 1 to the n, should be even? I'm sorry, that all of this number is positive, and therefore n should be even, because of the following. When you raise 0.2 to n exponent, this has to be by necessity positive, guys. It's impossible that you raise 0.2 to n exponent and have a negative value. It's impossible. So this is positive. And since this is positive, then clearly this must be positive. If this was negative, then I should have negative times positive equals negative, which is not the case. So this is positive, and my discovery is that n should be even, because when n is even, when you raise minus 1 to any even exponent, you should get a positive number. I know I'm saying too many things. Repeat the video as many times as you need in order to understand what I said. And so basically, let me erase this. Let me erase this. I know that n is even. I know that n is even, and therefore I can be completely sure that this number, minus 1 to the n, is simply plus 1. That's it. And then I can continue writing this equation. 0.2 to the n equals 0.0016. Very well. Okay, and I mean, I might as well erase this plus 1, right? It's multiplying this, so it's not really affecting anything, and that's it. I have bypassed this, the problem of the base being negative, because now all I have to do is solve this equation. Let's write down the logarithmic equivalent to this equation. The logarithmic equivalent is going to be logarithm base 0.2 of 0.0016 is going to be equal to n. And that's it. I have found a way to calculate n through this operation. Logarithm with this base of this number. So let's go to the TI. So here we go. The logarithm is right here, as you can see, it's right there. So let's press Control. Let's press that key. Logarithm. We have the structure logarithm base blank of blank. So let's write down logarithm base 0.2 of 0.0016. Enter, and the answer is 4. So conclusion, n is gonna be 4. And what is n? N is the number of terms that we are adding, right? So basically we're just adding this one, this one, this one, and the next one. That's it. Conclusion to the problem: find the number of terms in the series, just 4.